In the pursuit of a sustainable future, the world is increasingly turning to green energy solutions. However, one of the most significant challenges in this transition is the issue of energy storage. As we move towards a greener energy landscape, the need for efficient, environmentally friendly, and scalable energy storage solutions becomes paramount. Enter gravity batteries, a revolutionary concept that could transform our cities into massive energy storage units, with skyscrapers leading the charge. The need for better energy storage. The shift towards renewable energy sources like solar and wind power brings with it an inherent problem: intermittency. Solar panels generate electricity only when the sun shines, and wind turbines are productive only when the wind blows. This variability in energy production doesn't always align with peak energy demand, creating a mismatch between supply and consumption. Traditional battery solutions, primarily lithium-ion batteries, have been the go-to option for energy storage. However, these batteries come with significant drawbacks. They require rare and often environmentally destructive resources for production, have a limited lifespan, and struggle to meet the massive scale required for grid-level energy storage. Moreover, the efficiency of lithium-ion batteries degrades over time, a phenomenon familiar to anyone who has owned a smartphone for more than a year. The gravity battery concept. Enter gravity batteries, a refreshingly simple yet ingenious solution to the energy storage conundrum. The concept behind gravity batteries is elegantly straightforward. They store energy by lifting heavy objects and generate electricity by lowering them. This method harnesses the power of potential energy, a fundamental principle of physics. When excess energy is available, for instance, on a particularly sunny or windy day, the system uses this energy to lift a heavy mass. This process converts electrical energy into potential energy. When electricity is needed, the mass is lowered, and its potential energy is converted back into electrical energy through a generator. The beauty of gravity batteries lies in their simplicity and durability. Unlike chemical batteries, they don't rely on rare materials or complex chemical reactions. Instead, they use basic mechanical principles, resulting in a system that can operate for decades with minimal degradation. Existing applications: pumped storage, hydropower. The concept of gravity batteries isn't entirely new. In fact, we've been using a form of gravity battery for years in the shape of pumped storage hydropower. This system involves two water reservoirs at different elevations. During periods of excess energy production, water is pumped to the higher reservoir. When energy is needed, the water is released, flowing downhill through turbines to generate electricity. While effective, pumped storage hydropower has its limitations. It requires specific geographical features and can have significant environmental impacts, such as disrupting wildlife habitats and altering natural water flows. These drawbacks have spurred engineers and architects to explore alternative designs for gravity battery systems. Innovative gravity battery designs. The simplicity of the gravity battery concept has inspired a variety of creative designs. Some proposals involve using abandoned mine shafts or mountainsides as the vertical space for raising and lowering weights. Others suggest oceanic solutions, using the vast depths of the sea as the drop zone for energy-generating weights. More unconventional ideas have also emerged. One intriguing concept involved an octopus-style crane that would build and dismantle a tower of concrete blocks. Another proposal suggested using small trains running up and down hills to store and release energy. While some of these ideas may seem far-fetched, they demonstrate the versatility and potential of the gravity battery concept. Skyscrapers as batteries, a revolutionary approach. Perhaps the most exciting development in gravity battery technology is the concept of integrating these systems into urban skyscrapers. This innovative approach, spearheaded by the architects behind the Burj Khalifa in collaboration with gravity battery designers, proposes to incorporate large-scale pumped hydro energy storage systems into the very structure of high-rise buildings. In this design, the core of the skyscraper would essentially function as a vertical pumped storage hydropower system. Water would be stored in tanks at higher floors during periods of excess energy production. When electricity is needed, this water would be released, flowing down through turbines to generate power. The system would then pump the water back up when energy is abundant, creating a continuous cycle of energy storage and generation. Advantages of skyscraper batteries. The skyscraper battery concept offers several significant advantages. Urban integration. These systems can be seamlessly incorporated into urban environments, where energy demand is highest. This eliminates the need for long-distance energy transmission, reducing infrastructure costs and energy losses. Minimal environmental impact. Unlike traditional pumped storage systems, skyscraper batteries don't require the alteration of natural landscapes or the creation of large reservoirs, minimizing ecological disruption. Efficient use of space. By integrating energy storage into existing or planned buildings, this approach maximizes the use of urban space, a precious commodity in growing cities. Longevity. The mechanical nature of gravity batteries means they can operate for decades with minimal degradation, far outlasting chemical battery alternatives. Scalability. The size and capacity of these systems can be tailored to the specific needs of different buildings and communities. Challenges and considerations. While the concept of skyscraper batteries is promising, it's not without challenges. The additional weight and structural requirements of water storage tanks would need to be carefully considered in building design. There's also the question of retrofitting existing skyscrapers, which may prove challenging or impractical in some cases. Moreover, the initial investment for such systems could be substantial. However, proponents argue that the long-term benefits, both economic and environmental, would outweigh the upfront costs. The broader impact on green energy. The development of efficient, large-scale energy storage solutions like gravity batteries is crucial for the widespread adoption of renewable energy sources. By providing a means to store excess energy and release it on demand, these systems can help balance the grid and make renewable energy more reliable and practical on a large scale. Furthermore, the visibility of skyscraper batteries in urban landscapes could serve as a powerful symbol of a city's commitment to sustainability. This could inspire further innovation and adoption of green technologies in urban planning and development. Conclusion. As we strive towards a greener energy future, innovative solutions like gravity batteries, particularly in the form of skyscraper energy storage systems, offer a glimpse of what that future might look like. By turning our urban skylines into massive batteries, we can tackle the challenge of energy storage in a way that is efficient, sustainable, and integrated into our daily lives. The simplicity of the gravity battery concept, essentially lifting something up and then letting it fall, belies its potential to revolutionize how we think about and implement energy storage. As these technologies continue to develop and mature, they could play a crucial role in our transition to a more sustainable energy landscape. While there are still hurdles to overcome, the promise of skyscraper batteries and other gravity-based energy storage systems is clear. They represent a creative, scalable, and environmentally friendly approach to one of the most pressing challenges in our shift towards renewable energy. As we look to the future, it's innovations like these that give us hope for a greener, more sustainable world, one where our cities don't just consume energy, but store and generate it too.